The first of the two major methods for finding exoplanets is what we call the radial velocity method, or the Doppler method, because it depends on something known as the Doppler effect, or the Doppler shift. And that has to do with the wave nature of light. Remember, we had talked earlier when we talked about spectroscopy that waves are characterized by wavelength, the length of a single wave from crest to trough to the next crest, or from trough to the next trough. And the different waves have different wavelengths. And we saw that this was the basis of understanding the whole entire electromagnetic spectrum, the whole range of electromagnetic radiation that differ in wavelength. So radio waves are very long wavelength, gamma rays are very short wavelength. And we saw that that actually relates to the energy that the wave is carrying, and therefore depends on the temperature of the object that's emitting the wavelengths. So one factor that determines the wavelength of light coming from an object is its temperature. But there's also a second factor that will affect the wavelength, and that is motion. So if you have an object that's stationary, it's giving out a wave of a particular wavelength. But if that object is moving towards you, let's say you're over here, if that object is moving towards you, then the motion of that object is going to cause the waves to bunch up, and you will end up with a shorter wavelength. On the other hand, if the same object is moving away from you, what we call recession, then as it moves away, the waves get stretched out as a result of the motion, and you will get longer wavelengths. And in fact, the amount of this Doppler effect depends on the speed. If an object is moving towards you faster, the waves bunch up more and you get shorter wavelengths. If it's moving away from you faster, then the waves stretch out more and you get an even longer wavelength. So how much of this Doppler effect there is will give you an indication of how fast the object is moving, and whether the waves are bunched up or stretched out tells you whether the object is moving towards you or away from you. We see this effect in anything that emits waves. An approach causes waves to bunch up, giving you a shorter wavelength. A recession causes the waves to stretch out, giving you a longer wavelength. And one place where you see this, and you'll be familiar with this, is in sound, because the pitch of a sound depends on the wavelength. So as an object is approaching you, the wavelengths bunch up, you get a shorter wavelength, and therefore you would hear a higher pitch. On the other hand, an object moving away from you or receding from you, the waves stretch out due to the Doppler effect, and you get a lower pitch. And this is a very familiar phenomenon to all of us that's illustrated in this video clip. So that higher pitch as the car is approaching is a result of the Doppler effect. Once it passes and then it's receding, you get the lower pitch, so you get that effect. And let me leave you with one more video clip to make sure that you understand this concept of the Doppler effect or the Doppler shift.
I want to talk to you about before we go to the party.
I don't care if anybody gets it. I'm going as the Doppler effect.
No, it's not.
If I have to, I can demonstrate. So what time does the costume parade start?
The parade?
Yeah, so the judges can give out the prizes for best costume. You know, most frightening, most authentic, most accurate visualization of a scientific principle.
Oh, Sheldon, I'm sorry, but there aren't going to be any parades or judges or prizes.
This party is just going to suck.
Oh, come on, it's going to be fun, and you all look great. I mean, look at you, Thor, and oh, Peter Pan, that's so cute.
Actually, Penny, he's wrong.
I'm Peter Pan!
I got a handful of pixie dust with your name on it.
No, you don't. Hey, what's Sheldon supposed to be?
Oh, he's the Doppler effect.
Yes. It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
Oh, sure, I see it now, the Doppler effect. All right, I got a shower. You guys, make yourselves comfortable.
Okay.
See? People get it.
Nice.
Hello.
So what are you supposed to be?
Me? I'll give you a hint. Meow.
A choo-choo train?
Close. Meow.
A brain-damaged choo-choo train?
I still don't get it.
I'm the Doppler effect.
Okay, if that is some sort of learning disability, I think it's very insensitive.
Why don't you just tell people you're a zebra?
Well, why don't you just tell people you're one of the 7 dwarves?
Because I'm Frodo.
Yes, well, I'm the Doppler effect.